A survey was done at a local hospital to determine how long clerical staff had been in their current positions. The responses of clerical staff members were, in months, 25, 22, 7, and so on. Construct a modified box plot. A box plot includes information about the data, including the minimum value of the data, the first quartile, the median, the third quartile, and the maximum. A modified box plot potentially includes also a lower fence and an upper fence. So, to get this information, especially Q1, the median, and Q3, we need an ordered list of the data. Since they're not ordered for us, it's our job to order them. So we'll go here and take a look. Single digit numbers in the data are 6, 3, and 7. So the first three, the lowest three observations are 3, 6, and 7. Between 10 and 20, we have a 15, 17, a 14, and 18, and looks like that's about it. So 14, 15, 17, and 18. Those are all the numbers between 10 and 20. So in the 20s, we have 20, 22, 25, 24, 26, 22 with 29. So there are lots of numbers in the 20s, starting with 20. A couple of 22s and a 24. So that takes care of the 22s and a 24. There's a 25. Put that in there. Then we have another 25, 25, 26. So another 25. 26, and then 29. That's the last one in the 20s. So we'll move on to the 30s. We have a 32, a 31, and a 31. So a couple of 31s and a 32. And finally, what's left? A 42 and a 72. So we have a 42 and a 72. Now we can start calculating these numbers, starting with the easy stuff. Let's go with the minimum. We just look at the data, and the minimum value is 3. The maximum value is 72. And now we can start calculating indices. So these are index. We're going to calculate the index of Q1, which is 1 plus 0.25 times the number of observations minus 1. So back up for just a minute. We need to know how many data values we have here. So the sample size. So we just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So n is 20, which means we need to use in the formula for the index, we need to use n minus 1 or 19. 1/4 of 19 is 4.75 plus 1, 5.75. For the median, similar calculation, except we use 1/2 or 0.5 instead of a quarter. 1/2 of 19 is 9.5, so we have 10.5 here. Q3, 1 plus 0.75 times 19, which is 15.25. And remember, these are the indices. So we want to actually calculate these numbers. We have to look inside the data set, the ordered list, to get Q1. We look at the 5th and the 6th numbers and average them. 1, 2, 3, 4, 5, 6. So the 5th and the 6th numbers are 15 and 17, the average of which is 16. So here we're calculating 15 plus 17 over 2. Okay, it's the number that's exactly in the middle of those two guys, which of course is 16. The median is the average of the 10th and the 11th because our index is 10.5. So this was 6, 7, 8, 9, 10, 10, and 11. The average of those two is 23. And then Q3, we look at the 15th and the 16th. So this was 11, 12, 13, 14, 15, and 16. So the average of those, average of 29 and 31, is 30. And again, this is 29 plus 31 over 2. We're taking an average. The upper and lower fences are calculated by adding 1.5 IQR to Q3 and subtracting 1.5 IQRs from Q1. So we begin with the IQR, which is Q3 minus Q1. IQR, Q3 minus Q1. And don't look here, remember this is the index. This is the index for these guys. We actually have to look over here for the data. So Q3 minus Q1 is 30 minus 16. 30 minus 16, or 14. This information we're done with. 1.5 IQR, we just take that 14, multiply by 1.5, that's 21. So the lower fence, we add subtract 1.5 IQRs from Q1. So this is 16 minus 21, negative 5. Remember that's 16 minus 21. The upper fence is 1.5 IQRs above Q3. So we take Q3, add 21, and we get an upper fence of 51. So that's 30 plus 21. Now to draw the box plot, we take this information and put it down. So the lower fence is below the minimum, so we don't have any outliers on the low end. So we're not going to plot the lower fence. We're going to plot the minimum on the left side. But on the right side, we do have data that's above the upper fence. So that means we plot the upper fence and do not plot the maximum. Instead, we're going to have stars or asterisks or X marks or something to indicate the potential outliers, anything greater than 51. Okay, so let's get to it. Our box plot, it still has to include all the data, so it has to include all the numbers from 3 to 72. A reasonable choice for the width here is to go from 0 to 75, and that breaks up nicely into increments of 25, which then break up nicely into intervals of 5. And now we start to plot the data. So the minimum is 3, so that means we have the left side of the whisker at 3. Q1 is at 16, so 5, 10, 15, 16 is right about here. And we have a whisker. The median is 23. Here's 25, so 23 is right about here. The Q3, the third quartile, is at 30, so that's right here. And now we have the box for the box and whisker plot. And now we work on the right-hand whisker. And again, we're going to use the upper fence instead of the maximum for the right side because we have data that land outside the fences. So anything greater than 51 will be plotted as an X or an asterisk or something. And if we go back to the data, the only number that's greater than 51 is this one. So we're going to have one mark on our box plot out at 72. So here it is. We mark 72. That's a potential outlier. And the only thing missing from the box plot now are our nice labels. So remember, we were talking about how long clerical staff were in their current positions in months. So I'm going to title this Longevity of Clerical Staff and the axis is in months.